Hi guys, welcome you all to my channel Explore Edu to Teach.
Today we'll be learning another important concept in digital electronics, that is the KMAP reduction, and solve some problems regarding that. We'll be taking certain gate numericals also and solving them so that you have a better understanding about the concept. Before watching this video, it's my humble request, please go through the previous video in which I have given you the introduction of KMAP, that is Karnaugh maps, and the basic rules and regulations for that. This video you can find in the I button also, and also in the digital electronics playlist on my channel. Please go and watch it out. I'll try to include the summary in this video also, but if you watch that video, you'll get a clear understanding about Karnaugh maps, about K maps, and some basics of it. That will help you to do the numericals over here. So please go and watch out that video and then come back to this video. Also, if you like the particular video, do not forget to like, share, subscribe to my YouTube channel, follow me on Instagram, and share it to as many people as you can so that everyone can get benefited out of it. So let's begin. So first of all, KMAP is one of the methodology of reducing a particular Boolean algebra expression. Okay, so how do you do it? I will just give you certain rules. How do you do it? And once you know the rules, we'll try to apply them in the form of numericals. I hope I'm very clear with this. So in the last class, I told you how to first of all prepare this KMAP. What are these numbers 00011110? I had explained all of these things in the last video. So if you haven't watched that video, please go and watch it out. So first of all, when we are trying to reduce a particular expression with the help of a K-map, what are the important and the essential things are that we'll always first try to do the grouping. Grouping of what? It can be grouping of ones or it can be grouping of zeros. In 16 group, 8 group, 4 group, 2 group, or 1 group. So that is very important. So what is very essential or very important is we are always trying to do the grouping of K maps in the form of 16 ka group. If 16 is not possible, then 8 ka group or 4 ka group, 1 ka group, 2 ka group, or 1 ka group. This grouping can be of all the number of ones or all the number of zeros. It's up to you. So if you look over here, how do you do this grouping of 16? So if you see, it's a 16 by 16 matrix kind of thing. So in this, what happens, you can get all these 16 as one group. Fine. Then there can be groups of 8. So how can you do that grouping? I will show you. See, if you have a 3 variable kind of function given, you can directly take all this one as one group. If you have a 4 variable kind of table, which are A, B, C, D, and the ones are in this form, you can take all these ones as one group. So I'm showing the arrangements in which you can group the things. Then we'll be applying them onto the numericals. The notes are given down in the description box as well. Please download it from there. Again, it is the 4 variable matrix, and the group of ones can be like this 4, and this 4 can be taken as 1 8 group. Okay, again a 4 variable kind of function in which you have 4 ones over here and 4 ones over here, a total of 8 ones ka group. Then you have again a 4 by again then you have 16 groups table in which you have 4 variable, and you can make this also as 8 ka group. So I just showed you, if it is of course a 4 variable kind of thing, if you want to make a 16 ka group, so in that way all the particular boxes should have ones or it should have zeros, whatever is the thing, and you can make a group of 16. There can be a group of 8 in such a way. The initial 2 columns, there can be the initial and the final column, the initial row and the final row. You can make such form of groups. This also can be a form of group. So this is 8 grouping method. Then if 16 is not possible, as I told you, the priority starts with 16, then with 8, then with 4. So if 16 and 8 is not possible, then you can do it with 4. Now how do you do it with 4? See over here. We have this one, this one, this one, and this one over here. They form 4 group. Again this forms a 4 ka group, and again this forms a 4 ka group. So that is very essential. So these are the possible forms of grouping 4 number of ones. So one is over here, one is over here, one is over here, one is over here. So these all 4 form one group. Again, this all the 4s can form one group. Again, all these 4s can form one group. So just try to understand the arrangements in which I can group the number of ones in 16, 8, 4, so that you can reduce a particular expression with the help of KMAP using these rules. Again, this can be a group of 4. If you see, when there were all the ones were there, it was a group of 8. There were 8 ones. Here it is a group of 4 ones. Again, it's a group of 4. Then there are groups of 2. How is it possible? This one, then there is this one, and then there is this one. So that is again very important. These are groups of 2. So I hope that you are very clear how are we going to group. And for 1 to is just grouping one particular variable, so it's not a big thing. But I hope you understand how do we make the groupism. Then we'll try to apply it in the numericals that we have over here, and then see how can we reduce and apply those rules over here. So let us try to solve the first numerical. The question says, minimize the following expression using a KMAP. So if you see, it's a 4 variable KMAP, A, B, C, D, summation of M, 0, 1, 2, 6, 9, 12, 13. I told you in the last video also, if summation of M is given, it indicates it's a SOP, that is sum of products, and all these variables will be indicated by 1. Had it been pi M, it would have been POS. All the numbers over here would have been indicated in my table with 0. There is a numerical following this numerical in which we have POS. But first try to understand SOP. So what they have told is that they have given you this particular function A, B, C, D. They have given you summation of M, which is SOP, sum of products. And they have given all these variables over here, 0, 1, 2, 6, 9, 12, 13. All these variables can be mapped onto a particular table with one element because it is SOP. Had it been POS, had there been pi of M, if you see in the next numerical, we have pi of M. It becomes a POS. And I indicate all these variables with 0. So since it is summation of M, it's a SOP, sum of product, I'm going to indicate all these values with 1. So it's a 4 by 4 kind of table, a 4 variable table. I have shown you how to draw this table earlier in the earlier video. So if you haven't watched it out, please watch it out. So what we are doing is that AB comes over here, CD comes over here. AB can be indicated with 0, 0, 0, 0, 1, 1, 1, 1, 0, which is the ascending order of gray code. Again, CD can be given as 0, 0, 0, 1, 1, 1, 1, 0. Now AB can be, now 0 is indicated with bar and 1 is indicated with no bar. Okay, since it's a SOP, hence we have A bar, B bar, A bar, B, A, B, and A, B bar. Similarly, we have C bar, D bar, C bar, D, C, D, and C, D bar. And just indicate all these values which are there with the help of ones. Now the grouping can happen. Now as I told you, the first priority is to group 16 ka group. But if you see over here, all the boxes are not filled with 1. Hence, we cannot do a group of 16. Again, you cannot have a group of 8 also because the arrangements which I have showed you of group of 8 is not followed in this particular table. Hence, we can try to do group of 4. But again, group of 4 is not possible. So, we will do group of 2. So, what happens is, this one and this one forms group of 2. This one and this one forms group of 2. This one and this one forms group of 2. Now this one is again combined with this one, although this one is formed a group already with some other one, so that I can have a group of 2. I would have made this one individually only also, but I haven't made that, and I have made this one and this one as a group. This one is already associated to this particular one as a group of 2. But again, I have associated this one with this one so that it can be a group of 2. And as you know that group of 2 is a higher priority over group of 1. Hence, I'm reusing this one to make group with this. Fine. Now, how do you write down the expression? See over here. For this particular 1 and 1, we have A bar, B bar from this row, and from this column, only C bar is constant. Hence, we have A bar, B bar, C bar, plus we have, for this particular one, we have AB, again C bar constant in both this column, hence we have A, B, C bar. Next, for this one, we have C and D bar. If you see, you have got C and D bar, and A bar is common in this particular two rows, hence we have got A bar. Plus, for this one and this one, we have got B bar as constant in this row and this row, and C bar D, which is over here. So I hope I'm very clear with this. So you should know, in order to reduce a particular given function, for example, a 4 variable function ABCD, which is given in the form of summation of m, that is sum of products, onto a particular table, and reduce that table onto a given expression. I hope I'm very clear with this. Next, minimize the following expression using a KMAP. So there is the expression given to you, A, B, C, D. We have got pi of m. Now, since it's pi of m, I told you it indicates POS, that is product of sum, and the values given over here are going to be indicated in the KMAP table in the form of zeros. Had it been summation of m, it would have been sum of product, and I would have indicated those values in the form of 1. But since it is pi of m, it indicates POS, product of sum. I'm going to indicate those values in the form of zeros. So I hope I'm very clear with this. Now, as I told you in the last class also, since it is POS, not SOP, the 0 is given with no bar and the 1 is indicated with a bar. Fine. And how to place these values which are given over here onto this table is explained in the last video. You have to just form the values 0, 0, 0, 0 becomes 0. 0, 0, 0, 1 becomes 1, 0, 0, 1, 1 becomes 3. So all these values you can write, and the values which are over here represent those values in the form of 0 because it is a POS. So just write down those things, and then as I told you, our first aim is to make group of 16, which is not possible. Group of 8 is again not possible, but group of 4 is possible this time. If you see, all these 0 can be made in a group of 4. So what is the value going to be? It's going to be C bar plus D bar, because in all these 4 rows, nothing can be common. Hence, I'm only taking the column variable C bar plus D bar. Why I'm putting C bar plus D bar? Because it's product of sum. So all the sum values are going to be product, whereas here it is sum of products, that is sum of all the product values, where here, as the name suggests, product of sum. So all the values should be sum, and then the product should be formed of them. Then we have this particular 0 ka 4 ka group. Hence we have C bar plus A bar. Then we have this 0 which forms 2 ka group. Hence we have A bar plus B plus T. Fine. And then we have this zeros which is given as A plus B bar plus C. So in such a way we can find out this expression. Okay, you will have a little difficulty understanding of writing this expression if you have not watched my previous video, so please go and watch it out. Now this is a GATE instrumentation 2009 question, in which the question says the minimal SOP expression. So as soon as SOP is given to you, you should understand SOP stands for sum of products, and sum of product indicates that my table is going to be filled with ones, not 0. So the minimal SOP expression for logic function f represented by KMAP is given over here. Find out the reduce expression. Now see, it's a very beautiful question because they have indicated my table with 0 also and with 1 also. So they have confused the students by giving both 0 and 1, and they expect you to understand the meaning of SOP. If you know the meaning of SOP, you will know that it indicates summation of m, as in over here, and we only group ones. We don't group zeros. Had it been pi of m, it would have been a POS and I would have done the grouping of zeros. So it's a very beautiful question. It tells SOP, so you have to do grouping of ones, not grouping of zeros. Next, if you see, grouping of ones will be, it's the SOP sum of products. So we have for this 2, we have P bar, Q, R bar. Next we have for this 4 ones as Q into S. Then for this 2 1 we have R, S and P bar. So we have R, S and P bar. Then we have got this 2 1 which is given as P, Q, R. Next we have this 2 ones which is given as P, R bar and F. So I hope I'm very clear, and hence I've written for SOP you have to do grouping of 1 and just do the grouping. So what is very important in this part is you have to first understand how the grouping is done. The grouping is done in priority of 16, 8, 4, 2, 1. How to do the grouping I've told you. 16 is very simple. For 8, 4, 2, then when a summation of m is given, it is SOP. So we are going to first of all indicate all the values given over here in the form of 1, and 0 will be bar, 1 will be no bar. Is going to be sum of products, so all the individual values are going to be products, and then it's going to be sum of it. Similarly, your pi m is product of sum. It's going to be indicated with 0, as you can see over here. It's going to be indicated with 0. And most importantly, the grouping is possible, as I told you, with the kind of rules which I told. So make those groupings over here and move ahead. Similarly, you have an instrumentation gate paper in which the question was given for SOP. The table had both zeros and 1. So it was a very good question. You should understand the SOP is there. I have to only consider 1, not the zeros. Make the grouping for it. Start from 16. 16 is not possible because all the columns are not filled with 16. Then do 8. 8 is again not possible. Then we'll try to do 4. Then we'll try to do 2 and try to find out the answer. So I hope I'm very clear with this. I've tried my best to explain you the important things. So do not forget to like, share, subscribe to my YouTube channel, follow me on Instagram, and there are regular updates on Instagram also regarding all the videos coming up about all the formula sheets of all the shortcut techniques and everything. So do not forget to follow me on Instagram also. The links are given down in the description box. Thank you so much guys. God bless you.